Hello, class. I'm Amy. I'm the instructor for Math 221. Very excited to teach this class. It's been quite a while since I've gotten to teach Calculus 3. I do Calculus every semester, usually like a Calc 1 or Calc 2. I've been doing that, probably taught it now 50 times since graduate school, sometimes multiple times a semester. But I haven't taught Calculus 3 in about 15 years. One of the reasons I love teaching Calculus 3 so much is that it's a very visual, practical, has many applications in physics, computer science, most of the sciences and businesses. And it's also very related to my area of research, which is operations research. So I actually got my PhD in a lesser known field of math called operations research. Studied at NC State and then did a postdoc there. And then just kept working my way south. I'm from Maryland, so I stopped at NC State for about 8 years and then came down here and took the job at the College of Charleston to teach math, and I'm the operations research specialist in the math department. So I'm really hoping that many of you will love Calculus 3 so much that you may continue on. I teach a couple other classes in the math department closer to my area of specialty. I do a 451, 551, so an undergraduate graduate class in operations research, and one in optimization. And Calc 3 is the main prerequisite for those classes. So I'm hoping I'll get to see quite a few of you for multiple semesters in a row, and hopefully in person. So again, this is the first time in a while teaching Calc 3, but it's also the first time teaching online. And so I'd love feedback as we proceed, and I'll be asking for some exit surveys as we go through our modules. It's things that I can do to refine this class as we go. Yeah, so then I guess a few other things, maybe tell you about my research. So I mentioned that I have a degree in operations research, and I try to describe that as like sort of a applied math. And when I was in graduate school, I really got the bug for thinking about optimization problems, and particularly ranking. And so I started studying how search engines like Google did their rankings, and it turned out there was a lot of math behind that. In fact, it was something called a Markov chain, which is what I had done my dissertation on. And so studied that for a couple of years, wrote a book about that, and then continued on thinking about ranking and clustering of items. And so just in general, you have a subset of items and you want to know, how can I rank these from first to last place, or how can I group similar items into groups? And so lots of applications for those, but I really like to study the mathematical underpinnings of those. Wrote another book about that, Who's Number One? The Science of Rating and Ranking. And most recently, I've been working on something that I'm calling rankability, and that is a data set's inherent ability to produce a ranking. So a lot of times people take a data set, and there's so many ranking methods now, they'll apply a ranking method. PageRank is one of the most famous. That's the one that's used by Google for their search engine. So people will apply that ranking, and the question is, for me, from a mathematical foundational perspective, I want to know, is there something about that data set that actually makes it rankable in the first place? So just because you can apply a method doesn't necessarily mean that you should be doing that. Yeah, so I've been working with some colleagues, Paul Anderson, a computer scientist, and Tim Chartier, a colleague at Davidson in math and computer science. So it's a blending of many fields to think about rankability. Let's see, yeah, I do the Barton books. So that's the Google book, and then Who's Number One? And you'll see a little bit of calculus and optimization in those books too, actually. Yeah, and then when I'm not doing that, I think I mentioned in the syllabus some of my hobbies. Once upon a time, I did a lot of basketball and a good bit of volleyball. In fact, that's how I met my husband, a pickup volleyball game. And then most recently, I was doing a good bit of jujitsu. I have a brown belt in jujitsu and was teaching the women's self-defense class on campus, and got that thing up and started running. And most recently, probably the last 10 years, I've really gotten, I guess I would say, addicted to surfing. So whenever we have free time, we're usually get in a van and start traveling and finding surf. So during my last sabbatical, my husband and I and a couple dogs got in a van, traveled across the country to Canada, down the west coast of Canada in the US, catching surf, and then came back to Florida, went to the Keys, no surf there, but surfed all the way up Florida, all the way up the coast to Maine and Nova Scotia and the Canadian coast on the East Coast. So great trip, great time. In between all that I was able to think about rankability, and that's one of the things that I love about math is I can take it anywhere And I don't need, most of the time, I just need a notebook and a pencil. And in my brain, I can take it when I'm walking, go anywhere with it. Okay, so enough about me. Hopefully I'll get to learn about you guys and your teammates in similar videos or documents that you'll produce for us to meet each other. And even though this is going to end up being a larger class, I think we'll still be able to build community and have many activities designed for that. Okay, so the next thing is just a brief, like very, very brief introduction to the class. We'll have much more of that in other videos. But one thing that is very exciting, I think, about Calculus 3 is it really broadens your perspective of mathematics. So far, your mathematical life has been constrained usually to 2 dimensions for the most part. This is where you did everything. Y was a function of x, and you analyzed that, and we took derivatives, we got areas under curves, all sorts of things, but we were always restricted to this plane, the xy plane. And now in Calc 3, we're going to add another dimension. And so if I'm trying to draw this 3-dimensional thing on a 2-dimensional whiteboard, that kind of skew things. But we have the x, y, z axes now, and we'll be looking at this semester. Z is a function of x and y, 2 variables, and beyond. We'll even be going to 4 dimensions, and actually it's n dimensions we can do. Much of the analysis and much of the ideas hold in the tools that we'll use. But when we're visualizing things, we'll be here in 3-dimensional space. And actually, it's more appropriate to say in the world that we live in. This is 3-dimensional space. And so we can analyze all sorts of surfaces. Yeah, so we'll spend some time with things like this. This is a little folded origami style, but it's something that's called a polytope, and it's made up of a bunch of planes that are intersecting. And so we'll be able to visualize 3-dimensional objects. And of course, any type of surface, right? So if I take a paper towel or something, or cloth and put it over something, well, this is now a surface, and it is nonlinear bending, and we can do all sorts of analysis on those. And that is the crux of what we're going to do in Calculus 3 this semester. I'm very much looking forward to meeting you guys and having a good time this semester. All right, thank you.